Since February 2008, this prototype of the VARIOBASE jacket stands near Bremerhaven, erected by WeserWind GmbH Offshore Construction Georgsmarienhütte on behalf of Repower Systems AG. 340 tons of steel had been used to form a 57-meter tall structure which spans over an area of about 17 by 17 meters. In the future, this modular construction, made of standard elements, is going to carry wind power stations at sea and cope with enormous demands under extreme weather conditions. The engineers of WeserWind GmbH Offshore Construction Georgsmarienhütte are familiar with these difficulties through years of practice. Through successful projects in the area of offshore structures, they have gained the most profound experience, which now also is being used in developing and manufacturing the jacket foundation structure. The foundation structures, called the jackets, are a construction of standard tubes which are welded together with the so-called cast iron knots. As custom-made pieces, they are already used in the offshore gas and oil industry to work for foundations in larger depth of water. Their serial use in the offshore wind industry enables wind park sites in waters of over 20 meters in depth. In cooperation with the plant manufacturer Repower Systems AG Osnabrück, the experts of WeserWind GmbH Offshore Construction Georgsmarienhütte, using computer-based scientific algorithms, developed the basic design of the structure, which is capable of meeting the enormous requirements at sea. To calculate lifetime expectancy, extensive calculations and simulations using the finite element method are carried out. Computer-aided, the construction also is optimized regarding the material used. Parallel to preparing the plans for construction itself, the engineers also plan the production and erection process in order to illustrate the serial nature of the enterprise. During this project phase, modern computer technology is used for processing and simulating the workflow. All processes are adjusted in order to be engaged with each other smoothly. The assembly equipment is a custom product and equally adjusted to the series production. Knot geometries made of cast steel show many advantages over welded or screwed component connections. They can easily be produced with highest precision and optimal wall thickness, and through gradual change in section thickness, they ensure the best possible distribution of forces. Through the research project OGOWIN, funded by the German Ministry for the Environment, the development of these cast iron knots has been supported. The structure now is optimized to ensure an extremely high strength of the knots with minimal use of material. The Friedrich-Wilhelms-Hütte Stahlguss GmbH is one of the few foundries in Europe which possesses the technology to produce thin-walled components with sufficient static strength. Here they use processes which help to optimize the features of the steel in a way that cast and steel elements can be well welded together. To ensure this, the steel used is equipped with a low-carbon equivalent. Special analyses and adjustments are carried out in the warp converter. Through target-specific heat treatment, the necessary mechanical values are adjusted. Because of the thin walls of the cast iron knots, the casting itself is carried out at a temperature of over 1600 degrees Celsius. Both the casting and the solidification process are tested beforehand in a computer simulation. After the heat treatment, cleaning, examining and measuring, the knots are ready for transportation. In the Bundesanstalt für Materialprüfung, the Federal German Institute for Materials Testing, the first static load tests are carried out on the cast iron knots with a servo-hydraulic examining machine which is unique in Europe. Here strain gauges, fiber sensors and three-dimensional visual measuring systems are used to record the stress conditions and the changes of geometry. With these test methods, the cast iron knot is thoroughly examined in several steps, beginning with 0 meganewton through normal operating workload up to the maximum load of the plant. Even though this particular value exceeds the estimated operational load by more than 50% already, the knot shows no negative reactions. In a further test, the knot is then loaded up to the testing tool's maximum load of 25 meganewton to check its behavior in these extreme conditions. The knot also endures this procedure without any damage. With the company Europipe GmbH, we found one of the largest and most experienced manufacturers of tubes for natural gas pipelines worldwide, a supplier for the required standard tubes. Here at Europipe GmbH, tubes using more than 1 million tons of steel per year are manufactured under strict quality controls. The ultra-modern process covers all the necessary steps, from pig iron, rolling the metals, through molding U and O shapes, up to the welding and the final strict quality control. In this way, standard tubes of the highest quality and availability are made for the VARIOBASE jacket. The cast iron knots are welded together with the tubes of Europipe GmbH in the production facilities of the affiliated company at the site in Osnabrück. This is carried out here automatically with highest precision in the so-called submerged arc welding process, providing high-quality standards and short production times. While planning size and weight of the cast iron knots and tube construction, we already consider the optimal workflow of the component's future transport. Heavy load foundations are put in place in May 2007. These provide the firm connection to the ground, a task which in offshore operations is performed by the so-called pile sleeves. By mid-August 2007, the construction of the heavy load and crane foundations is completed and the assembly areas are prepared. The onshore construction of the offshore jacket structure is ready to start. To ensure scheduled production order and optimal final assembly, the logistics of the foundation structure is carefully planned, tried and computer tested until the best option has been found. The segments of the VARIOBASE jacket are prepared on the ground for assembly and welding. It is important that the parts are lined up in perfect order. Then the structures can be covered and joined together for welding. The VARIOBASE jacket is erected with the help of one big mobile crane and two small ones. This construction phase has also been planned beforehand in every detail in computer simulations. Thanks to this careful preparation, the complete assembly and erection proceeds smoothly. In late afternoon, the foundation structure stands upright. The work has been worthwhile. Thanks to the concept of producing with standard components and the use of series production, the VARIOBASE jacket foundation structure will contribute to make wind energy more effective in the future. In November 2008, the building of the series production facility of WeserWind GmbH Offshore Construction Georgsmarienhütte at the site in Bremerhaven will start. Due to long-dated cooperations and contracts, the necessary material resources for this serial production could be secured already for the years to come. WeserWind GmbH Offshore Construction Georgsmarienhütte therefore fulfills its dues for a future-oriented, sustainable and clean energy production in the future.